Hello, everybody. We're here. Don't worry about the time slide. We are delighted to have Ali Azad Hasan, my bad, Business Development Executive in the IoT Smart Cities team at Amazon. And he's also in the Worldwide Partners Group. And he's kind enough to spend some time. He actually lives up north. So we're delighted to have him, another superstar that lives in the Austin Metroplex. Please welcome Ali Hasan. Give him a hand, please.
Thanks. Can you guys hear me okay? Nope. Now can you hear me okay? Better-ish? Oh, I just heard myself. All right. Hey, everyone. I don't know what Andres said over there. He was going around saying Amazon, Amazon. I don't know what he said to bring you guys in the room. I have no giveaways. I have no echo dots, nothing. I come bearing nothing. But yeah, like Andres said, Ali Hasan, I manage the partner ecosystem in our worldwide public sector organization, which basically means partners that operate in the IoT, smart city space, smart lighting, parking, data aggregation, et cetera. We help them build IoT solutions on AWS and then help them go to market with those solutions. Today I wanted to spend a little time talking about, it doesn't work from here. Next one, please. There you go. So yeah, I kind of wanted to, actually let me by show of hands, does everyone understand the concept of cloud computing? Okay, almost everyone does, good. So I can skip through a lot of my slides. I'm going to touch a little bit high level what cloud computing is, because I feel like every conversation I have, it's still a bit of one-on-one does help. I want to spend a little time talking about just data in general. We heard a lot from different panelists earlier about the data problem, the aggregation of data, how to manipulate it, how to use it. Very briefly talk about the technology. And then because my focus is primarily with smart cities, I'm going to talk a little bit about some use cases, case studies where we're applying IoT, AI, and ML in these industries. And then next one, please. Oh, this takes a little getting used to. So everyone knows Amazon as originally the book company, right? Sold books online. But then the way this thing started was in 2006, Amazon realized that what they had built with their massive data infrastructures and the way they were operating them and operationalizing them was very unique and operating at scale, and it's something that they could take to market to our customers. So in 2006, AWS, which is Amazon Web Services, was born out of Amazon and became basically what started off as cloud computing. For anyone that doesn't know, cloud computing is basically simply the concept of taking IT resources and providing them on an as-needed basis with a pay-as-you-go model. Right? So the idea is, hey, I need to scale up my IT resources. You don't need to go deploy new data centers or new servers. You just basically click a few buttons, launch some virtual instances, and you can scale up. And then vice versa, when you don't need those, you can scale them down. So it gives you a lot of flexibility in leveraging IT resources. Today, AWS has about, we have this concept of regions and availability zones. Availability zone is a cluster of one or more actual physical data centers. And then region could typically be a logical arrangement of all those AZs, availability zones. So we have about 25 regions globally. These, in some cases, are countries. In some cases, just parts of the country. In the US, you have East and West, and then we have a GovCloud region, which is for the government, which gives you the same level of security, but then you have added compliance, FedRAMP certifications, CGIS, et cetera, that meet all those compliances. So we provide all the compute, storage, database services, but then on top of that, we layer on all the higher level services around analytics, IoT, AI, ML, prediction, predictive maintenance, managed services around that, right? So holistically, the cloud sort of offers you your soup to nuts in being able to extract data, store it, compute on it, analyze it, visualize it, and be able to get some business insights out of it. Next one, please. So the reason people tend to choose cloud, and you guys might be familiar with all of this, is a few. Primarily, it's the idea of trading your capital expenditure versus variable expenditure, right? The cost to spin up a data center, the cost to manage those data centers, the heating, cooling that goes into that is significantly high. So as opposed to dealing with those capital expenditures, the idea is on a pay-as-you-go needed basis, you can now turn those on the variable expenses and then also benefit from the economies of scale, because the data centers that Amazon AWS builds are pretty massive in scale, and we generate a lot of economies of scale by operating that way. And what that means is usually the cost to operate those goes down, which we turn around and pass back to our customers. So since 2006, AWS has proactively decreased prices across our services about 107 times. Right? So we tend to turn back and offer those savings back to our customers. The other reason is capacity planning. It's tough to anticipate what kind of capacity you're going to need when you're building IT infrastructures, and also with demand changing up and down, especially with the pandemic. We saw a lot of Zoom being an example we were talking about earlier. We saw how their demand skyrocketed with us being at home. How do you quickly spin up these resources without having to plan and over provision or under provision resources? So the cloud helps over there as well. And then also the ability to, once you've got your solutions, applications in the cloud, how do you take it to the next level, right? Data has gravity. So getting data in the cloud is useful, but once it's in the cloud, there's additional things you can do with the data. You can try out new projects, and the risk of failing is a lot lower, because if you go to an IT project manager and say, hey, or an IT project manager comes in and says, I want to start something new, I want to try a new project, but it's going to cost X, Y, Z, the chances of that passing through is going to be tough, because obviously the ROI is unknown, right? Whereas with cloud computing, because of those variable costs, it's easier to take chances, it's easier to take risks, and if it works, great. If it fails, yeah, you lost money, but you lost it for the portion that you were actually leveraging these resources, right? So it becomes easier for companies to innovate because of the flexibility. Next one, please. So all of this is great, but it's all pretty useless if it doesn't line up with your goals. And typically, wherever you are, whether you're a private enterprise or public sector, the way I see it, goals usually come down to three things, right? One, how do I take my current operations and how do I improve them? Whether that's improving the operation. We talked about Industry 4.0 earlier. How do we take current processes and improve them? How do we take the current operations, improve them, and even reduce costs, right? The second element is, how do I lower something? So in cases of enterprises, it might be lower costs. How do I lower my risk? In public sector, it's the same thing, right? How do I do more with less? I have limited resources in public sector. How do I get more done for my citizens? How do I engage my citizens without having to spin up or hire more people or just expand the IT team? Because IT teams tend to be lean. And then the last one is probably one of the most important. How do I grow my revenue or grow new revenue streams? And again, private, public sector, similar examples, right? In public sector, again, I deal with smart cities. How do I increase my parking revenue? How do I create digital platforms so citizens can engage and I can collect more taxes because that's my revenue? Or how do I launch new products that help me generate a new revenue stream? So those are the business goals that we see. And then if you move to the next slide, AWS helps you achieve those goals through a bit of a process, right? So the idea is we want to obviously encourage partners to our customers to migrate their workloads to the AWS cloud. We have a lot of programs built around that, and then we offer a lot of credits and stuff. But migration is just the first step. It's a big step. It takes a lot of planning, and we suggest you start with your simplest workload that you have flexibility on, and then start with that, right? Mission critical stuff can work, but you might want to start with that a little later. Take a small workload and migrate to the cloud and just see. And then obviously security, right? So security is inherent in all the services that AWS provides. So we want to make sure it's in the cloud, it's secure, it's scalable, and then you're adopting modern application or modern methods. So there's a traditional way of building applications, the more monolithic way. But then at AWS, we kind of came up with this new serverless concept, which you might be familiar with. The idea is I don't even need to provision actual servers. I'll just use compute resources when I need them. So we have something on Lambda, which basically means when I have an actual call, that's when I want to spin up a resource. I want to leverage the serverless computing and turn it back down when the call is done, right? So you're not even actually spinning up actual physical servers or virtual servers. You're just doing these calls in and out to make things happen. So just modern ways of creating applications. And then obviously apply the added level services on top. Next one, please. So this also is not easy. There's still a lot of companies out there that have not migrated to the cloud for good reason in some cases. And then also because it's a bit of a process, right? And the trend we're seeing is, again, going back to IoT, there is a lot of sensors being connected to the network, which are generating a ton of data, right? So data itself is valuable, but it's also becoming a problem because companies, a lot of companies and cities went through this wave of smart city where the idea was, hey, let's connect the sensor and we're going to be smart, right? And they did that. And they connected all the sensors. They have all these databases, but what do you do with that data? How do you manage this extensive data? And what is the cost of managing that data on premise? So those are some of the challenges we see customers run into. And then I talked about this earlier, but how do I, if all my data is collected, but it's sitting in silos, I have transportation data on one side, I have industry data on the other side, I have process automation data on the other side, right? What's the point if all this data is sitting in silos and it's not interacting or correlating with each other? Or it's not been normalized, right? Because data coming from temperature sensors could look and feel different than data coming from pressure sensors. So how do you collectively normalize this data, bring it to a single format where now applications can understand across different data sets? And then once you understand that, how do you apply machine learning on top to basically get some insights and intelligence out of that? So that's where the cloud provides a lot of value, just because, like I said, data has gravity. So once it's in the cloud, you can help add additional capabilities to it. I'm going to skip this, but the idea is a lot of this data is being generated by tons and tons of IoT sensors. Everyone hopefully understands IoT. It's the idea of all these connected devices at home or in factories. And IoT adoption at home has been a lot faster than it has been commercial and enterprises, just because the nature of the impact it has is a little different, right? Next one. So we kind of, next slide, please. Yeah, thanks. So I talked a lot about IoT and data and warehouses and stuff, but the idea is we want to start the discussion with problems, right? If we start every presentation on this way, if you had the state of every data, the state of every sensor, every device, every data that's connected, and then could reason on top of that, what problems would you solve? So at AWS, we have this working backwards concept, and the idea is let's work with the end customer, try to understand what are the challenges they're running into, what are the problems, and then work backwards from that to understand what technology, what data makes sense, what processes make sense, right? So that's why I want everyone to think about, say, what are the challenges, what are the problems we want to address if we could understand the state of every data out there, or every sensor out there. Next one. Let's do the next one as well. I'll skip this one. I want to stay on track on time. So I talked a bit about IoT. Now we heard a lot about AI and ML, but I kind of wanted to take a step back and sort of define the way we see these different elements, right? So the way we see AI is a broader umbrella where basically it's any technique that lets computers or machines not replace, but basically take human intelligence and add it to it, right? So it could be logic processing, it could be deep learning. ML is a subset, we feel, of, you could go ahead and build out the slide, sorry. So the broader umbrella we see as AI, and then below that, machine learning is the idea of taking data and deriving patterns from that, right? So it's a subset. Machine learning for us is a subset of the overall AI concept. And if you go one step, so at the machine learning stage, we're still leveraging data sets, and we're trying to understand patterns or doing some prediction from that, right? If you go one step below that, deep learning is the idea where we're basically using neural networks and doing multi-layered intelligence, right? So the idea of voice recognition, natural language processing, image recognition, visual recognition, those are things where the machine is sort of going a step further than just looking at data. It's applying some logic and trying to understand, hey, this looks like a person, this looks like an object, or this sounds like a female, male, right? So it's kind of going a little deeper into that. So we look at this from a multi-layered approach, and these terms obviously are very interchangeable in the industry, but we're kind of breaking them down just to understand where things fit. Next one, please. So when I talk to customers and stuff, when people hear about AI, there's this big idea of this big artificial intelligence robot machine that's going to control everything, right? For AWS, it's a little simpler than that. The idea is, how do we take regular applications, human processes that are available today, and add basic AI machine learning to that to improve the processes, right? It's not focused on heavy robotics and stuff, and we have solutions for that. But how do we take basic things like chatbots, right, and add some intelligence to that? How do we take basic things like BI tools, business tools, and add some level of forecasting or predictive maintenance intelligence to that? How do we take text, right? We have a service called TextTrack where we basically take any written document, take a picture, scan it, send it to the cloud. It'll scan the document, convert it to text. Simple, right? It's just taking that simple concept of taking document scanning to the next level where it digitizes it. We have Recognition, which is an image recognition service where you could put up any picture and it'll tell you the sex of the person, the probability of that person being male, female, and then the gender, that kind of stuff, right? So it's just taking those basic things and how do we apply machine learning to that so it becomes everyday usable. It's not the far-fetched future stuff. It's just how do we make these things smarter. We have tools that let you take data sets and then do some level of sales forecasting based on the data that's available. So that's how we're applying machine learning in everyday use cases. Next one. All right, so next one. Yeah. So it's a busy slide, but I just wanted to kind of highlight the broad set of services, deep and broad set of services that we have in this space. So if you look on this side, the bottom segment for IoT, we have what we call device software. So these are services that are focused on the actual sensors, devices. Some of them are open source. It's the idea of how do we apply services right on the microprocessor sensors and help them connect to either a gateway or connect back to the cloud, right? If you go to the set above, those are core IoT services that sit in the cloud. How do we ingest this data? How do we secure it? And how do we manage the fleet of devices that are available? So, it could be applied to solutions as simple as 10, 20, 30, 100 devices, and as big as millions and millions of devices that are connected. It's the same services, very highly scalable. Then if we go one step above that, within the IoT realm, we still have, we still have, once the data is in the cloud, how do we apply analytics to it? How do we leverage some sort of event management to that? And then in this industry factory automation space, we have a managed service called IoT Sitewise, which basically lets you do factory automation and extraction of data from sensors, visualize it all as a package solution. So IoT on the left side is a set of services that help you extract that data, store it, but on the right, or I guess my right, are all our machine learning services. And if you look at this, at the top we have SageMaker, which is basically our machine learning core platform. But then as we go down, these are the different services I was talking about around recognition, for visual recognition. We have TextTrack, we have Poly, which is basically taking everything that Alexa does, extracting those services out and providing them to our customers. So the speech recognition service that Alexa has, we take that out and now offer it as a service if you want to build your own device, right? Transcribe is transcription services, forecast. So it's all these different layers of machine learning and AI that you can now peel out and apply to your applications as needed, as opposed to looking at this overall thing. Next one, please. So who's our biggest test bed? It's Amazon, right? So, and just so you know, within Amazon, AWS is the computing segment, Amazon.com, the retail segment, is basically our customer. So we kind of treat them like our customer, like anyone else. So Amazon, as everyone knows, is a massive operation, right? So everything we've learned, and Andy Jassy, who used to be the CEO of AWS, basically says that, I forget what he says. He says a lot. I forget what he says. Oh yeah, there's no encryption engine for experience. Yeah, those are those words. He basically says there's no compression. There's no compression engine for experience, right? So the experience that Amazon has gathered by deploying massive amount of data centers, the robotics, and the sensors that have been deployed in there, a lot of that translates to us testing our services and knowing that they're scalable, they operate, and now we're going to work for a lot of our customers, right? So if you go to the next slide, you'll see that over time, the way Amazon generates thousands of products and how we sell these products, the intelligence that goes into that is based on all the AWS services, the packages that are shipped out, all the logistics, the supply chain, the technology behind that is a lot of the AWS services. And then the idea from IoT scalability, there are billions of Alexa devices. All of those connect back to AWS IoT Core. They're managed from the same device management capabilities. So all of these services I'm talking about have been tested at thorough scale at our own customers, right? And Amazon being our own customer. Outside of that, we obviously have other customers, but then Amazon tends to be the biggest one we have. Next one. So I kind of want to move a little bit into the smart city portion now, because I kind of focus on that area. Smart city, everyone knows, is a pretty big market, right? IDC claims it's like a $190 billion market, but again, smart city is a very loose term. It gets used around a lot, and I think it's different definition for everyone. So if we move to the next slide, the way we kind of focus on smart is not just being able to connect devices, that's just the first step, but then doing some sort of real-time integration of the data that comes out of that with some sort of historical databases, right? How do you understand patterns by saying, hey, here's a historical database, this is how the devices behaved in the past, and now they're behaving this way. How do we compare those things? We do some data modeling, we do analytics, machine learning, and then be able to visualize all of that into a usable format for the end customer. That's, to us, that's really what makes any solution smart, and it's not just the connection of the devices, right? That alone is not useful. Next one, please. So I like this quote because everything I'm talking about sounds great on slides, but we all know this is a journey, right? And it needs to be taken in incremental steps, and each step should provide some ROI, and each step should add to the overall vision. So I think it's important to keep that vision in mind, but then realize it's going to be a journey, and along the journey, every initiative we do should have some sort of value that it provides, right? So it's, that's why I thought I'd throw it in this here. Next one, please. So from a smart city perspective, we have a pretty holistic ecosystem that we provide, right? So everything, like I said, starts from the customer back. That's a big obsession at Amazon. So if you look over there, we kind of take the vision of the cities or communities or whatever you want to call it, and work backwards from that to understand what are your needs, what are your challenges, and then what are the right applications that would apply to them, right? So we have over 100,000 partners in our partner network, and then we take their solutions and we provide them on a marketplace similar to Amazon.com. So just the same way I would go on Amazon.com to buy diapers for my 2-year-old, similarly, you can go to the AWS marketplace and procure software that applies to smart city challenges, right? So we provide those resources from our cities, and then when you extract the data and provide it in the cloud, we want to be able to create some sort of analytics or some visualization on top of that. And then any insights that are gained, we want to be able to provide them back to the city. So this becomes like a virtuous cycle where you're basically getting insights from the data and then providing them right back to the city so they keep improving. And the core platform, AWS, sits right in the middle, and we're providing an ecosystem of partners, services, training to help enable these cities. Next one, please. So this is just an example of the large ecosystem of partners we have. We have everything from edge compute partners, and some of them I saw on the board over here, Siemens, Itron, et cetera, all the way to connectivity, solutions, and then the SIs, consulting partners that help integrate all that. And there's a ton more. They're all on our APN page. But just to give you an idea that our primary go-to-market is through partners, right? So everything we do is primarily through partners. Customers can build stuff on AWS as well, but partners play a very pivotal role in this. Next one, please. So I don't know how I'm doing on time, but I kind of wanted to talk about, all right, cool. Couple of examples, right? So in public sector, we work with partners in cities. So the city of Detroit had a massive traffic management problem where basically they had over 800 traffic signals and 2,500 miles of roadway, and they had zero visibility into the status of these traffic signals, right? So they needed some way to connect these, get visibility into it, and then not having to send out truck rolls to actually repair these things when they go down. So Maya Vision is a partner of ours that has a solution called Traffic Link. They basically remotely connect these devices, the traffic signal controllers, stream the data to the cloud, the status of all this. They're leveraging AWS IoT Core, and then they're now able to provide a full visibility into the traffic signal controllers, right? So that itself was a huge benefit for the city. They went down, it says over here, from 8 hours of travel times, congestion down to 2 hours, just by getting visibility into when traffic signals go down, when they should be repaired, and when they should roll out, so I know what the problem is. And then on top of that, they applied some machine learning to understand what are the traffic patterns, right? Where are we seeing the highest congestion? Where are we seeing, what times are we seeing traffic congestion grow? So just simple examples of where they took the IoT services to connect the devices, then they applied the machine learning on top to do predictive traffic patterns to say, you know, during these times we're anticipating more traffic, maybe you open up a different corridor and stuff like that. Next one. Another example is in smart cities, we have a partner called Rubicon. What Rubicon, they're a waste management company. And so they have a bunch of truck rolls that go out, garbage trucks that pick up waste management. What they did is they realized that their trucks are the biggest mobile asset in a city. So their trucks are always going in and out in all the different neighborhoods and streets. So they're in the best condition to get the real-time status of a city or of the road conditions, right? So they attached a bunch of sensors to their trucks, camera, pressure sensors, and different sensors. And they basically started saying, we're going to turn our truck into a mobile data center. So they started collecting data on road conditions while their truck is going through that every day. They start collecting data on fire hydrants, if there's a broken fire hydrant, if there's potholes, what's the environmental air quality in the certain area, all of that data, and then they collected that, presented it into a smart city dashboard, and now they offer that to the cities to say, hey, our trucks can be your eyes on the road just through leveraging these IoT services and machine learning and stuff, and now we can tell you what the active condition of the road and the environmental is, more than a city would know just by deploying a bunch of sensors, right? So it's just a unique way of taking technology and understanding what else can we do with it. If it's basic fleet management, that's great, but what other data can I derive from that? Next one, please. So I'm going to start wrapping up, but I kind of want to talk about this concept of, there's an organization called Fireware. Is anyone familiar with Fireware? Oh, there you go, one hand, perfect. And there's a reason for that. The reason is because F-I-W-A-R-E, Fireware. They're basically a smart city consortium. Their focus primarily right now is Europe, EU. So they have about 190 countries that have signed up with them, and they're basically building an open standards-based framework for smart cities to collect their data and correlate it, share it amongst each other to get insights while preserving privacy and security and autonomy, all those things, right? So the Fireware Consortium has built the architecture for that. AWS is working with Fireware, we're partners with them, to create this framework. So now the idea is if you're a city and you're saying, hey, I want to build a central framework, I want to ingest existing deployments I've done, I've already got some solutions out there, I want to procure new solutions, but I want all of this to go into a single framework, and I want a context broker in the middle that can take the data, understand the context of the data, and now push it out to the right application or the use case of the right department, right? But I want that central platform in the middle to manage all of this. AWS provides this architecture to our customers to say, if you work with Fireware, this is how you would ideally deploy this. And this is not locked in to AWS services. This is just an architecture. We show you how to implement this with AWS, but you could go do this with non-AWS services as well. Obviously, we wouldn't like that, but we want to keep it open. We want to keep it available. Fireware is starting to make inroads in North America, so they're opening chapters over here, and there are a couple of cities that have started working with them. But we kind of see this as a forthcoming trend in North America, and we kind of want to start working closely with them to understand where we can apply this over here as well. Next one. Yeah, I kind of talked about this. And next one, please. Yeah, so I'm going to wrap up by saying from a smart city perspective, we host a challenge every year. It's called City on a Cloud, and the idea is if you're a customer or if you're a partner, doesn't matter, if you have an idea If you have a challenge, if you have a concept, a proof of concept, if it's real, that's great. If it's not even real, if it's just on paper, that's fine. Submit it, right? And we have a host of judges panel that manage all of this stuff. I'm sorry, the third party. They go through all the challenges, and every year they select a set of winners, and we then turn around and give them credits, $10,000, $50,000, $100,000 worth of credits to say, let's materialize this. Let's see how we can build this, make this happen, and make it a reality, right? How do we apply Amazon's innovation principles? How do we apply our technologies and work with you to help make this into a reality, right? So we've got a lot of startups that have submitted ideas. We've got cities that have come in and said, this is our vision. We want to pick these 2 challenges and see if we can execute on these. So that's where AWS comes in and applies all our resources. And we actually also have something we call cloud innovation centers. They're basically hubs. One is in ASU, Arizona State University. The other is in Cal Poly. We work with these universities. And the ASU one is focused on smart city. And the idea is if you're any city anywhere, not just in Arizona, and you have a challenge, any sort of challenge, right? You have a homelessness challenge. You have a opioid challenge, pandemic, transportation, mobility, whatever. Bring that challenge to that group. That group works with AWS. That group works with the students at the university and the engineering department. And together they help build some sort of a solution by applying technology. And that solution gets published open source for everyone else to share. So ASU has gone through a ton of, and all these challenges are listed on their website. ASU has gone through a ton of different challenges and actually turned them into realities. And some turn into production, some don't. But the idea is we want to foster this idea of innovate, build, try. If it works, great. If it doesn't, fail, move on to the next thing. So with that, I'm going to wrap up and hopefully move forward to the panel.
Excellent.
Thank you.